Hi, I'm Colette Belinsky from Dr. Elizabeth Wayne's lab, and I'll be presenting our work testing the antiviral ability of metal printed mask material against human coronavirus. So during this pandemic, a need for antimicrobial and antiviral materials was made very apparent. Even as this pandemic begins its conclusion, hopefully due to vaccine distribution, we anticipate that the need for antiviral materials will not disappear. Places with a high volume of people touching common surfaces easily spread virus. So these sorts of places, like gyms, for example, can use antiviral material to better protect people. In this current pandemic, one of the key mitigation strategies has been wearing a mask in public. So in this project, we endeavored to test the ability of metal printed cloth to kill human coronavirus. The metal printed material, as well as funding for the project, was provided by LiquidX, a company based here in Pittsburgh. So to test this, we exposed human alpha coronavirus, which is a different type of coronavirus than the one seen in this pandemic, to different mask materials. So we tested silver, copper, and zinc printed cloth compared to the cloth without any printed metal and a surgical mask. So after exposing these materials to the virus for either 10 minutes, 1 hour, or 2 hours, we serially diluted the virus and exposed the dilution to MRC5 cells, which are a type of lung cell. These cells were then monitored over a 5-day period with any cells that displayed cytopathic effect marked. We then found the TCID50 value using a read and munch table, which allowed us to determine the titer or concentration of the virus. So to test this, we had made 2 stocks of virus from the original alpha coronavirus purchased by the ATCC. And the titers of our created stocks can be seen in the table in the middle. So we used the lower titer stock to determine at what time points antiviral effect began to occur. For these experiments, we tested the virus after being exposed to the mask materials for 10 minutes and then an hour. So from this, we were able to see that after an hour, the silver printed material was able to significantly decrease the concentration of the virus compared to the control material, as well as the zinc printed material. Using the higher titer of stock, we tested the materials for longer time points and included another control, which is the surgical mask. Again, we saw that the silver printed material significantly decreased the virus's titer compared to both the surgical mask and the zinc printed material. So during these experiments, we also tested copper printed material. However, the MRC5 cells are apparently copper sensitive, and the copper was cytotoxic to them. So this left us unable to perform an accurate TCID50. So from these results, we concluded that silver printed material was the most effective antiviral mask, and that the zinc showed no appreciable antiviral effect. This in itself was a bit surprising, considering zinc has been shown to have some antiviral effect against viruses like HIV and influenza. But this is still an ongoing project, so we have a few aims for our upcoming experimentation. Firstly, we want to determine the limit of this antiviral effect. And we want to do this by using a stock virus that has a higher initial titer. We're hoping this will let us determine the limit of how much virus can be killed by these mask materials. Secondly, we want to test the efficacy of copper printed materials. And we plan on doing this by using a different cell line that is not sensitive to copper. We want to increase the accuracy and precision of these measurements by performing back titers with each of our upcoming runs, so that we will be aware of any variations in the stock virus's titer as a result of freeze-thaw cycles. Lastly, we would like to see if the effectiveness we saw in silver printed materials, or silver printed cloth specifically, is seen on other silver printed materials like nitrile for gloves or PET for clear barriers. I would like to thank everyone at Wayne Lab for their help and contributions to this project, as well as LiquidX for mask materials and funding. Thank you for watching.